sounds so much more complicated than it is. Remainder theorem states that when a polynomial p of x is divided by a binomial x minus a, the remainder will be pa. Why, of course it will be. Remainder theorem states that when a polynomial p of x is divided by a binomial x minus a, the remainder will be p of a. What remainder theorem is a really quick way to determine the remainder without actually doing the dividing. Remainder theorem is a quick way to determine the remainder without actually doing the remainder. Why? Why would we need to do that? Because we need that to do the factoring that's coming. Why do we need to do the factoring? Well, what's the goal of this unit? The graphing. So this always going to relate back to graphing. Remainder theorem says that you take the binomial and you set it equal to 0 and solve for x, just like we've done in everything else so far this unit. Look how crisp and nice that felt marker is. So step number 1, take the binomial, equate equal to 0 and solve, just like we did for synthetic division, just like we've done a bajillion times. What does x have to equal? 3. The second step says you take whatever the polynomial is and you sub in 3. So that's just function notation back from grade 10. P just means the polynomial. The 3 in brackets just means replace x for 3. So I'm going to take the polynomial. I'm going to take out the x after the 11, put in 3. I'm going to take the x and put it to the 4th. And then I've got a minus 7. And all remainder theorem says is that whatever that's equal to, that's the remainder. So we have to do some bedmass here. What comes first in bedmass? Brackets. There's nothing I can simplify in the brackets. After brackets comes exponent. So I would need to do the 3 to the 4th first. 3 times 3. And another 3 times 3. No, listen. 3 times 3. And another 3 times 3 is another 9. And a 9 times 9 is 81. What's after exponent? Division. Yes, which I don't have. So I've got a multiplication here, I got a multiplication here, and then I got that negative 7 just hanging around. 11 times 3. 4 times 81, we'll do 4 times 80, which is the same as 4 times 8 with a 0. So 4 times 80 is 320, and then 4 times 1. Put those together to get 4 times 81. 324. And then I got a minus 7 hanging around. Then it's just collecting the like terms, so just adding it up. I'd let you use a calculator for this one. Offer?
Negative 298.
That sounded confirmed at the same time? All remainder theorem is saying is when you divide that polynomial by that binomial, you get a leftover of negative 298. Wow. It's just a quick way to do the remainder without doing all the division. It's going to save you work once we get down to the factoring. Factor theorem says, you can't see that, factor theorem says, states that a binomial x minus a is a factor of a polynomial p of x if and only if p of a equals 0. Factor theorem states this binomial x minus a is a factor of a polynomial p of x if and only if p of a equals 0. It's really the same thing as remainder theorem. What it's saying is if you get a remainder of 0, it divides evenly. If it divides evenly, it's a factor. That's all this is saying, is if you do exactly what we did above and you get a number of 0, yes, that binomial is a factor. So example number 2, verify that x minus 1 is a factor of this big long thing. Again, this is just a quick way to determine, is this a factor without having to do all the division. Step number 1, we take the binomial, equate to 0, and solve. So x minus 1 equals 0, x equals 1. It's saying stick 1 into this polynomial, simplify, and we want to know if the answer is 0. So I've got 1 cubed plus 2 times 1 squared minus 1 minus 2. This would be a non-calc, so we would expect you to do simple numbers like this in your head. 1 cubed, 1 squared, times 2, we'll do in the same step. One plus 2, minus 1, minus 2. It's really the exact same thing as remainder theorem. It's just saying if this is 0, what's the conclusion about the binomial?
Factor Z.
Yes, it is a factor. So yes, x minus 1 is a factor. Which should make sense because when something divides evenly, you don't get a remainder. That's all remainder and factor theorem are telling you. It's a quick way to determine if something's a factor and get the remainder without actually having to do the division. Verify that x plus 2 is a factor of f of x equals x squared plus 3x minus 7. So as of yesterday, what you would have done is try to factor that binomial to determine. That's out now. Factor theorem is in. Step number 1, take the binomial, equate to 0, and solve for x. If x plus 2 equals 0, x equals. Why am I suddenly using an f notation? And in the previous examples, I used a p. It's because this is given in the question. They have given it specifically as f of x. I just realized I should have done that for 2 and didn't realize it. Yeah, just realized it. So negative 2 squared plus 3 times negative 2 minus 7. Again, this would be an example of a non-calc question. We would expect you to be able to do simple exponents in your head. Negative 2 squared, 3 times negative 2. 4 minus 6 minus 7. What does that tell you? No, not a factor. What is this negative 9? It's the remainder. So it's factor and remainder theorem all in one because it tells you if it's a factor and it gives you the remainder if it's not. Again, it's just a fast way to be able to tell without having to do all that division because that's going to save us time when we get down to the factoring. What the heck is number 4? So you might want to just jot down this is an application of factor theorem. So one of those questions where it's a little bit backwards, but it doesn't tell you it's an application. So when you look at this at the exam, you need to figure out that this is factor/remainder theorem. What are some keywords in the question that's going to tell you on the exam to use factor/remainder theorem? Factor, I would highlight or underline. Not necessarily value of k. That's important to the question, but it's not going to really tell you it's factor/remainder theorem. What's another key part to the question? Whose cell phone keeps binging? Because it needs to stop. What is going on? What else is a key thing in this question to tell you it's factor/remainder theorem? The function. So the minute you see a big, long polynomial, this is going to be factor/remainder theorem. So highlight the polynomial and highlight where it asks, is it a factor? Or where it says is a factor. So this one's a little bit backwards. They're telling you it is a factor, and they want you to find this missing value for k. Well, what do you know if something is a factor of a polynomial? You know that if you sub in that value, the answer has to be 0. So let's sub in the value. What's the value I need to sub in? Where does that come from, negative 2? X plus 2 equals 0, solving for x. So I know I'm going to have negative 2 cubed plus k times negative 2 squared minus 5 times negative 2 minus 7. And I know this has to equal 0. How do we know it has to equal 0? Because they told you it was a factor. Okay, what would you do first? Before getting k by itself, I would go to, somebody said it over there, exponents. We want to simplify it first, so let's do the 2 exponents. Negative 2 cubed.
Negative 8.
Negative 2 squared. And then times k I'm going to write as 4k, because we would typically put the coefficient first. Negative 5 times negative 2. And then that negative 7. What would you do next? Simplify, move everything to one side. I heard it at the same time. So let's simplify the three numbers. So negative 8 plus 10, 2 minus 7. K has to equal. Can it be a fraction? Because what's going to happen on the exam is you're going to start to doubt yourself at this point. You're going to go, whoa, fractions. I'm not sure I like fractions. Can a coefficient be a fraction? What's the only definition of a polynomial? So back from yesterday, what has to be a whole number? Just the exponents. So that coefficient is A-OK. So don't doubt yourself if you get a fraction, you get a fraction. There's your value of K. Okay, so there's an application of factor theorem just working backwards. Show me your thumb so far in remainder/factor theorem. Good, kind of good, good, good. Okay, so really what we're trying to do today is factor what's called higher order polynomials. We've talked about this guy before. When the degree is 3, what's his name? He's a cubic. I kind of mentioned it, but I didn't really mention it. What's it called when the highest degree is a 4?
A fourth degree polynomial?
Yes, but it has its own name. It's a quartic. Quartic. What if it's x to the 5? That's called a quintic.
And then from there we just like start saying.
And then we stop giving them special names because
From
they're
there, we
really,
start saying x
yeah.
polynomial.
Quintic. Pentagon? Yeah. But when you have 5 babies, what are they called? Quintuplets? Quints? That's where it comes from. Quads if there's 4. Could you imagine having 5 babies?